We are really happy to have you here in this webinar. So my name is Peter Stoss. Next to me is Alexander Karmazin. I just call him Alex, and if you call me Peter, I think that's easier for you to keep in mind. So I first want to introduce us a little bit. So we are both responsible for automotive products here at RA Consulting. We share the subdivisions of automotive products, and we are both quite experienced in OBD. I started with OBD even with the beginning of OBD2, so in the early 90s. I'm the originator of Diagra D and Silver Scan tool, and today we say the product owner of these tools, and I'm still working on OBD. So Alex has also many years, very deep experience in OBD and diagnostic protocols. He's coming from the other side, from the simulation side, this Diagra S. So he's the product owner of our tool Diagra S. And he has also a deep knowledge in ODX and PDU API, D-server, OTX, and he is a member of the SOVD working group. So we do our best today to have an interesting webinar about ZEVonUDS. So we have a large number of attendees in this webinar. This was really unexpected, and we are really overwhelmed about that. So we expect a wide range of knowledge from your side. So we try to keep it interesting for everybody. So we will start with an introduction of standards and OBD regulations, and then we will focus especially on DoIP, functionality of ZEVonUDS, and finally on the compliance test for ZEVonUDS. So we will change from time to time. So Alex will make the first part of the presentation. We have planned questions and answers at the end of this webinar. So all the questions you have, please add to the Q&A section. There's a special Q&A section in this meeting. In the background is Malte Richter, our colleague. He will observe everything you write in Q&A section, and afterwards we will, if possible, try to answer your questions. And of course, we have the media technical team in the other room. So we are quite excited, and I think we can get started.
Yeah.
So Alex, it's your turn. I will now disappear and return in a few minutes.
Okay. Great. Thank you, Peter, for introduction. So we will continue with the topic on ZEVonUDS and its rules, where it comes from which OBD regulations, and the main one where the main regulation there ZEVonUDS is coming is CARB ACC2, also Advanced Clean Cars 2 from CARB. It was developed in the year 2022 and published, and the goal of that regulation was that CARB wanted that light-duty zero-emission vehicles are reaching 100% of sales on the market and up to 2035, and they introduced quotes for that for different years, and also they introduced requirements for battery durability and warranty for battery and propulsion related parts. And also they added several requirements about firmware over the air updates. And also there are display requirements for the values displayed in the car, and they are even more bound to the warranty. Like the user of the car gets the warranty for the value corresponding to the value displayed in the car. And this regulation from CARB was also adopted by several other US states. So it's not just for California, it's also for New York, Washington, Colorado, Delaware, and so on. And what is more interesting for our today's topic, there is a document from CARB about standardized data requirements. So, and this is where we will talk about a bit more in details today, and where the ZEVonUDS is coming from. So data standardization requirements are applied from the model year 2026 for all ZEVs, and for at least 40% of models in this year or certified cars needs to fulfill these requirements, and the next year, so 2027, it is applied to all 100%. So interesting, in contrast to the other emission-related standards, there are no requirements for driver inducement and no MIL, so there is no such definition. It doesn't have to be present in the ZEVs. There are also very precise requirements on the standardized data required from all zero-emission vehicles. And this data is to be read by a generic scan tool of OBD port. So it is a change to what we have now on the market, because now in the market there are many zero-emission vehicles, but to read out the data, there is no standard, and you need to use an OEM-specific tool, and you need to have an OEM-specific knowledge about that. And with this regulation, such tools like such generic scan tools like the Silver Scan tool or DiagnoD will be able to read the data out of the new vehicles. And this CARB regulation requires the new diagnostic standard, so SAE J1979-3, ZEVonUDS as a diagnostic protocol. So it's really required for all of ZEVs. And there are two options for data link. One is CAN, so like a classical one, like for all other emission-related vehicles, and DoIP. And DoIP is the first time CARB allowed this transport layer for emission-related diagnostics. So it's a kind of big change. What happened in parallel to CARB regulation? So in parallel to that, the UN regulation GTR 22 was developed, and it has many similarities to the CARB SEC2, but it has also some differences. Like it has no warranty requirements, and also there are some requirements for battery durability which are stricter at CARB SEC2 as by UN GTR 22. And also there is a difference, a significant difference in terminology about how the state of the vehicle is defined. So CARB SEC2 defines the state of health, but UN GTR 22 defines a state of certified energy and state of certified range. These measurements are quite similar from the understanding, but they are having different definitions. And as you see here in the table, where we try to put some of the differences and some of the common parts of both requirement documents. It is just our selections, a small one. It's just to give an impression how it is. Like vehicle odometer is required for both, but traction battery pack state of health is required only for CARB, and the state of certified energy is required for UN GTR 22, and so on. So that's there are much more of data requirements which are differentiating between both. UN GTR 22 will be also implemented by US EPA and as a main option, but EPA allowed CARB certified vehicles as an alternative option for light duty and medium duty. And UN GTR 22 will be also implemented by Euro 7 and related directives from Europeans like OBM and OBECM and so on. The contrast of European regulations is that they don't require any specific diagnostic protocol to be used. So even the classic OBD protocol might be used for that. So, and most of the data or the data required for electric vehicles is is defined in the range would be allowed for the classic OBD protocol, and also other countries will follow. But there are, maybe you heard about this, like this year there was something coming up in the news. So US Congress revoked the ACC2 waiver from CARB. So it means it is this regulation is not longer enforceable. And then the question arises, do we need a ZEVonUDS still, or is it it will disappear? And just to give an impression how it will develop. So CARB is trying to protest it in court, and if it wins in court against US Congress, then it will this regulation will apply immediately next day. And Euro 7 is referencing the UNR 154 regulation, but allows also a newer version of that regulation. So its current version is from 2022, but the newer version of regulation will be allowed as well. And the newer version in draft contains also ZEVonUDS as an option, and even for both CAN and DoIP. So it is expected to be allowed by Euro 7 as well. And also China 7 proposal includes ZEVonUDS. And and moreover, other countries will follow this UN regulation, and the protocol itself, ZEVonUDS, is now becoming an ISO standard, and there is a draft version of that, and so it means the standard will have hopefully a long life. So it makes totally sense to talk about this in details. At this place, I will forward the word to my colleague Peter back. So Peter, you can explain more about the ZEVonUDS.
So thank you, Alex. So I'm back. I will now talk a little bit about standards. So, and I have prepared a special slide. It's the timeline of diagnostic protocols. So don't be afraid. I'll try to keep it short. But it started really in the early 90s. So 1991, this was the very first OBD standard, the J1979, the first one, only with mode 1 to mode 9. Mode A, we had afterwards the connector, the J1962 connector. And some years later, we had kind of a, I would say, facelift of J1939. This was the introduction of keyword 2000 in the protocols. In the first version, we had only ISO 9149 and J1850, so special protocols. No CAN, of course, not yet. And then not OBD, but general diagnostics. In 1998, we already had UDS. So this is 27 years ago, quite a long time. And maybe you remember OBD on UDS was introduced in 2021. So it took quite a long time to convince CARB to introduce that. So in 2005, we had OBD on CAN, so the ISO CAN or ISO 15765 protocol, which is used today in nearly every car, I would say, together with UDS. Afterwards, this ISO CAN protocol became mandatory for OBD. And what is interesting for today, already in 2012, we had the ISO 13400, which is diagnostics over IP. And this is what we will focus today a bit on, UDS and diagnostics over IP. So the same year we had the worldwide harmonized OBD. This is called worldwide harmonized OBD. Even that it was only used in Europe for trucks and in China. It didn't become really worldwide harmonized, but later we had OBD on UDS, and you remember. And finally, today, ZEV on UDS. Why do I explain that? It's because of these three protocols are all based on UDS. They are all somehow OBD on UDS, but the name is used only for J1979-2 OBD on UDS. But all of them use UDS, all of them use the same data, so they are very similar, but there's quite different requirements and quite different functionalities. And what is really new now, we will mention this today in this webinar multiple times, this is that DoIP now, diagnostics over IP, is allowed for ZEV on UDS. This makes the big difference. So CAN is allowed or is used for all of these protocols. I have a summary about the OBD protocols prepared. It's something similar to the previous slide. But it was, I think, a good time to introduce OBD on UDS and ZEV on UDS, because UDS was already used by nearly everybody, all vehicle manufacturers. OBD functionality is a subset of UDS, especially on ZEV on UDS. It's rather a small subset of UDS. And the previous mode 1 and until to mode A are replaced by corresponding UDS services. There are only a few left. The most important one is the read data by identifier and read DTC information. I'll come to that back in the next slide. All the data are reduced, and what is also new is that the 2-byte DTCs have been replaced by 3-byte fault codes. Because it was the time that the standardizers then run out of DTCs at the time. So I've prepared a table. This is now comparing the classic J1979 to J1979-2 and 3. I want to explain that because I think it's important to know the background, to understand the background. I didn't want to talk only about ZEV on UDS. So we have in the first line this replacement of diagnostic services. So routine control, which was earlier mode A, is no more used for ZEV on UDS. We have the same database in the background, the same data definition. It's the J1979 digital annex. What is the first really big difference? In the classic OBD, we had single freeze frames only, one freeze frame for one DTC. And now we have on J1979-2 OBD on UDS, we have at least 5 for 5 DTCs, 2 freeze frames, the first and the last one. And surprise, for ZEV on UDS, we have no freeze frame at all. We still have confirmed and pending DTCs for all of these protocols. We have permanent DTCs for the classic OBD and OBD on UDS. But then we have another really big difference. Readiness test results and in-use performance data, some kind of groupings or summaries of many single DTCs, and it was grouped, and now we have an OBD on UDS. We have very detailed information for every DTC. I think you know that already, but we have just nothing for ZEV on UDS, so it's gone. And the next one is the routine. It's routine control. Routines was mode 8, and it's still used for OBD on UDS, but no more used for ZEV on UDS. Though there's really only a few items are left. It seems to be quite a small number of data. It's rather a small subset. But what is really the big improvement, once more, is DoIP. So Alex will explain that later in detail. So I want to talk about something else. We spent quite a lot of time to prepare this webinar, even to get some more background information. And there were many things that we came across. And one thing is I want to talk about is the terminology or the terms that are used in combustion engines and in electric vehicles. So everybody who is used to combustion engines, knows we have so-called emission critical ECUs or emission related ECUs. We have quite often used engine on or off, or ignition on and off. So we have a key to turn the ignition on and the engine on. And we have a definition for driving cycles. We have a definition for ignition cycles. And this is really important for compliance test and debouncing of faults. So to distinguish between a pending and a confirmed DTC. So this is all quite important, but it is not used anymore. What we see now in electric vehicles, the standard and the regulations, they only talk about ZEV propulsion system, about propulsion-related ECUs, about propulsion system active, or even propulsion system active trips. So there's no ignition cycle or driving cycle. I thought about that. What means propulsion system active? In electric vehicles, there's most cases no key to turn, but probably you have a button that you could push. What does it mean? The engine will not start it, because when the engine starts, you will immediately drive, but the lights will turn on. And next could be you press a pedal, you move to drive position, or do something else, press the button twice. So it's not really clear to the user what means propulsion system active and what is a trip. I thought about even something else. If you have a keyless entry system, what happens if you approach the vehicle? Could it happen that you have a trip even when you approach the vehicle? I know it's crazy. A lot of questions, and we don't have the answer, sorry. And we are not in the position to give answers to that. But we have learned that all of you have the same questions, and you all are looking for answers, and it's really hard to find them. But I found it's really exciting to think about that, because we have, when you talk about a compliance test, what can we do? And what shall we do with UDS? When a DTC is reported, we still have a pending or confirmed flag. How shall we deal with that? So for us as tool suppliers, it's quite simple. We just get the data and display them, but it's interesting to think about that. So what is new, I think, from data side, for ZEV on UDS, we have a couple of standard data that we are used to. It's vehicle speed, accelerator pedal, odometer, distances, different distances, and time since engine start. It means now time since propulsion system activated. It has changed a little bit. We have still the VIN and the CAL ID and the CVN. But what is new is we have a lot of battery-related data. So somehow voltage, current, energy, temperature, minimum, maximum, average data. We have charging data. So where does the energy come from? Is it grid energy, or is it a brake engine power? We have this, what Alex already said, we have the state of health, state of certified range, and state of certified energy, which are quite similar, but not the same. These are different data identifiers. And for fuel cell vehicles, we have all the fuel cell data. And many of the data are available twice as recent data for this trip, whatever it is, and lifetime data that will never be deleted. So it's a bunch of new data, a large number, and this is what is interesting. So I want to spend a few minutes quickly to show how does it look like. We have opened a SilverScan tool in the background and our simulation tool. So as I said, Alex is responsible for that, the simulation tool. It's Niagara S. We have prepared a project that Niagara S simulates. It can simulate even both a complete vehicle with multiple ECUs. It simulates the data and even the communication interface. So we have really a real-time communication now running as soon as I activate it. And SilverScan tool is connected to Niagara S. So I start the communication now. Something should happen. Yeah. First of all, the propulsion-related ECUs are detected. We get the current data or data stream parameters. We can, what is new now in this view compared to the old one, in case you know the old one from OBD Classic. We have a view of just seeing the data from one ECU or seeing the data from all ECUs on one screen. So we still have the fault codes. But we have no readiness, no freeze frames, no test results. Rationality is heavy duty. And we have some classic data on this information tab, like winner protocol ID. And most of the new data, the battery data, you will find on the tracking page. So, and we have no induced performance data. So everything that you probably know, so saving snapshots, running, recording the data over time, everything is still possible. So it's only a little bit different user interface. So I'm looking at the time, so we should move forward. This one, yeah, no, not yet, sorry. This one, yeah. Okay, so one product I want to mention is our XML to Excel. So the snapshot you can take with Niagara D or SilverScan tool. It's written into an XML file. You can import this XML file to XML to Excel. So this will create an Excel sheet. Every snapshot will get a new column. So in this sheet, so it's very easy to compare the data even from different snapshots. So another word to Niagara S, but I think I have explained most of it. The Niagara S is capable to do some more things. It's we have used now the pass-through API, but we also have an RP1210, which is used more for J1979 for heavy duty. We have this PDU API that we use for DoIP, but also for CAN protocols for anything else. We have implemented all the standardized APIs for interfaces. It can be used for any other tool. It's not especially designed to be used for the Niagara D and SilverScan tool. And it has some more capabilities. It can even work with ODX files and verify the data. You can create your own projects manually, and you can create projects very quickly from log files, from trace files we have taken with the Niagara D and SilverScan tool. So this was my part, and the next one, so Alex will now continue with some insights for DoIP.
Yeah, thank you, Peter. Yeah, we continue with the DoIP topic, and I think we already give an impression DoIP is important, but why? So why DoIP is different? Why it fits also new architectures? So yeah, because new architectures for the vehicles, so for software-defined vehicles, they have real PCs, also high-performance computers inside of the vehicle, and multiple of them. And for this computers is much more natural to communicate over Ethernet and not over CAN. So it's yeah, if you use DoIP-based, so as an IP-based protocol, then it's much better fit for them as CAN. And DoIP is generally faster than CAN, no surprise. Then the next one is that DoIP has more relaxed timing requirements as CAN. It's really interesting. So because for CAN, ISO 15765 requires for all ECUs to answer for the functional requests during the first 50 milliseconds with the first frame. And it's quite hard if you have a lot of ECUs, and with propulsion systems of zero-emission vehicles, it might be quite a big number, like 20 and more, and then 15 milliseconds for answering after the request is transmitted. It's really quite little of time. And DoIP makes it based on the total response which will be transferred, and the timings are much more relaxed. So it means like something like 5 seconds can be used to transfer all of the data needed, and with pendings, it can be, with response pending, it can be then extended. And Peter already said in his slide that DoIP is already is not new. So it was standardized like 13 years ago. So yeah, it's 2012. So it's 13 years, and many OEMs are already using this since many years, and for especially for their service tools. Not for emission related or not for legislated diagnostics, but especially for the use case of normal OEM specific stuff, OEM specific diagnostics. And because of that, there are also many VCIs capable to communicate over DoIP on the market. And even with that fact, the cheap OBD to the Ethernet adapter might be used for DoIP communication. And generally speaking about Ethernet, so cybersecurity aspects are playing an important role, but we don't go deeply in that topic today. How it looks like on the OBD connector. OBD connector defines 2 possible pin combinations for DoIP, so-called Ethernet option 1 and option 2. So for each of them, there are 4 pins used, like for normal Ethernet cable with 4 wires needed. And there is a special pin, number 8, which is used to activate these pins, because these pins are consuming a significant amount of energy. So for Ethernet, it's more as for CAN, and it makes sense to make it activable. So, and this so-called DoIP activation line can be set programmatically or manually. And additionally, so I said there are 2 options, but most of OEMs, as far as we know, are using option 1, and it is also recommended by the standard. And to communicate, you can use DoIP capable VCI, and there are also standardized protocols for VCIs like J1979-3 Ethernet NDs or DPDU API. Or you can use the cheap OBD to Ethernet adapter, so like the yellow, so typically it's yellow or orange one. So, and after the pins are activated, or DoIP activation line is set, the vehicle needs to get an IP address somehow, and it starts the receiving of the IP address over DHCP as a client, and over AutoIP, and the first one successful wins. So the total process will take about up to 7 seconds. So it's also regulated by the DoIP standard. So after 7 seconds, the vehicle should have an IP address. And the interesting part about DoIP is we are speaking about so-called DoIP server entities, which are located inside of the vehicle and representing the subnets of the vehicle. And there might be several of them. So let us have a closer look to this diagram. We have a generic scan tool like Silver Scan Tool or Diagram D, which is communicating over OBD interface to the vehicle. The vehicle is capable to establish an Ethernet communication. It has a WIN, sure, and it has 1 or more DoIP servers inside, and each DoIP server will have an own IP address, and it has a own logical address of the gateway, so or of the main ECU behind the DoIP server. And some of these servers might support ZEV, some of them not. What is important to know is that the generic scan tool, or generally this diagnostic tester, will try to connect to all of them separately and try to talk to all of them and try to identify what is supported or not. And behind these DoIP servers, there might be a couple of different ECUs which are accessible over this DoIP server, and some of these ECUs might support ZEVonUDS, some of them might not support ZEVonUDS, like ECU number 4 here. It is to be determined by the scan tool, and based on that result, we'll talk to these ECUs or not. This is how DoIP works. Even this picture is a bit more complicated, but what we learned, so typically the classical architectures of the vehicle in the past, they typically used just one DoIP server, like a gateway, which had a subnet of all of the ECUs available and managed the communication to all of them. But with new architectures evolving, it will be probably changing, and the whole subnets or parts of subnets will be visible also to outside of a vehicle. Yeah, it's quite an interesting topic. So how the DoIP communication is running? So the first, you need to identify the vehicle. And for that part, the UDP protocol is used. The tester needs to send a VIN request message and gets a VIN response from all of the DoIP servers, also DoIP entities. This VIN request is sent over broadcast and or multicast for IP version 6. Unicast is actually the special case which will be not used, because unicast assumes that the tester or the scan tool already knows the IP address of the target DoIP server, and that is typically not really known. So it might be also because of DHCP and AutoIP, it might be dynamic, or will be probably dynamic. And the UDP protocol is used also to get additional infos about DoIP entity, like power mode and entity status and so on. What you also need to know is that DoIP has different versions. So current version was free, so until this year. But also version 2 is compatible to version 3, and even version 4 released in this year is backward compatible to to version 3 and 2. So I put one screenshot for such a VIN requests here. The screenshot is it was created with open source tool Wireshark packet analyzer. It's just quite good and recommended if you are dealing with DoIP. And here you can see the message which was sent over DoIP, and it helps here to understand what is sent. So it was a vehicle identification request, and the response will contain a VIN and the logical address of the gateway and some more information about group ID and entity ID for this DoIP server. What happens next? So diagnostic tool also knows which DoIP servers are present, and it needs to start routing. So it's so-called routing activation. And it's at first the TCP connection to this DoIP server will be established by the diagnostic tool, and then the routing activation request will be sent. How it looks like. So let us have a closer look at that. So the routing activation request has bytes 3 and 4 set to 0005, and response would have a similar one, but with 06 at the end. The first 2 bytes, I didn't talk about that, but the first 2 bytes are containing the DoIP version information. In this case, it means that the message is formatted using DoIP version 2. So, and the second byte is just the inverse version, as it is like 255 minus 2. And the same is used on the other side for all of the requests and responses. The message contains also the logical test address, which is fixed for ZEVonUDS. It is 0E00, and it contains the routing activation type, because for OEM-specific diagnostics, there will be another value used, but for ZEV, there is a specific value which needs to be used. It is 01. And then there are also some bytes reserved here. Yeah, so they are just reserved for future use or for whatever, for some specific stuff, but currently they don't have really any meaning. In between, I skipped this part. This is the length of the bytes, of the following bytes, also starting here after the length. It is just a common convention in the DoIP protocol. So 0B means these are like 11 bytes which are following. Good DoIP entity answers with a similar response, with similar looking response. So it has 06 here in the fourth byte. It has a logical tester address, and it has an entity source address, like this DoIP server confirms, so I am, and this is my address, and I confirm this routing activation, and the value 10 in hex corresponds to the successful activation. Yeah, so I have also some screenshots in Wireshark for that. So Wireshark helps a lot, so you can see this data and the responses. And yeah, what happens next? The tester will send diagnostic messages, and the messages will be directed to a single DoIP entity, but might be redirected to the ECUs behind that. So this say, like every ECU that behind the DoIP server entity, there might be several ECUs which are supporting ZEV, and all of them having a kind of logical DoIP address, and this can be used in the requests just to point out to the specific ECU behind this entity. The tester can send functional or physical really addressed messages, but for ZEVonUDS, it is the functional addressing is limited to only one special case for protocol identification, at least for now. In future, it will be extended for other use cases like clearing DDCs, because it just makes sense to clear DDCs at all ECUs at once and not doing this one by one. But current version of ZEVonUDS doesn't allow this. There is a range of logical addresses of ECUs specified in ZEVonUDS, and so it's quite a big range, so up to, I don't know, so kind of several thousands of addresses possible. And each request message sent by the tester will be acknowledged by the DoIP server, so by the DoIP entity, the so-called diagnostic acknowledgement messenger. And after some time, so at least as late as like 5 seconds of response, or 10 seconds after response pendings, the response should be sent by the DoIP entity. In fact, it will be just retransmitted, because internal subnet will process it, and the DoIP entity is responsible to send this response from the internal subnet to the tester. One topic, TCP connections can be secured by TLS, but about that, there are no requirements in ZEVonUDS, so we will skip this topic for today. But we just keep it in mind so that it might be secured in the future. And I have an example how it might look like with a diagnostic message. So it's quite similar structure like before. So we have inverse version at first, then there is a specific number, 8001, which corresponds to a diagnostic message. When they have a length of the following bytes, then they have logical address of the tester, which is fixed for ZEVonUDS, and then they have a destination address, which is here just the functional address to be used to talk to all of the ECUs supporting ZEV. And they have a request message. It is just a protocol identification message to identify which ECUs are supporting ZEV. DoIP server will confirm this message by sending 8002 back, and then later on, for all ECUs, there will be a separate message with a response, and based on that, the diagnostic tester or generic scan tool will identify which ECUs are supporting ZEV. Yeah, so for all of them, I have also attached some screenshots from Wireshark, so it's, you can have a look at this. So the screenshots that we have created them based on the capturing of the traffic between our SilverScan tool and our simulator. Yeah, so that's it for my slides. So I will just quickly show you what you can do with the SilverScan tool for the DoIP, how it works. So if you want to communicate just over network adapters of your PC, assuming, for example, you have your vehicle connected over OBD to Ethernet adapter, then you need to select the virtual DoIP entity with a SilverScan tool here, and then SilverScan tool will switch the combo box to the DoIP standard. And what you might take into account are the settings for DoIP. Typically, you don't need to change anything, but there are a couple of settings which might be interesting. For example, broadcast IP address. I don't think you need to do that, but it might be needed for some very special cases for debugging. What is more interesting is a routing activation timeout. You might increase this time because if the gateway or DoIP server entities are needing more time to answer to the routing activation requests. But typically, it works just out of the box. Our simulator, DiagnoS, is running in the background. It's already configured to support DoIP as well. So I will just press a button for starting communication. And after a certain time, we get the dialog with the list of identified vehicles. Okay, we don't even get it because there was just one vehicle found. It was DiagnoS. It was represented by the simulator, and then it's automatically selected. So it was quite easy, and we see the data and can work with a SilverScan tool the same way you are used to for CAN. So yeah, you can read fault codes, current data, and vehicle information and tracking, and so on. I think it should be enough to get a first impression about how to use DoIP with SilverScan tool, and to understand how it's different in contrast to CAN. So, Peter, you can continue with compliance tests.
Yeah. Oh, okay, so I'm back and I'm checking the slides. Yeah. So now as the last topic for today before we go to the Q&A section. So please stay in the meeting. Yeah, we have been asked for a compliance test even I think a year ago, especially for ZEV on UDS. Because there was nothing on the market, compliance test is required by the OBD regulation, but there's something different compared to the compliance test we had all the years. You know, probably the J1979-3 compliance test for classic OBD. Now, this is maintained and by SAE working group, and there's only one single tool you should use. The same will be for OBD on UDS, the -5, but there's nothing similar for ZEV on UDS. We know they are working on that currently, but there's no requirement to use one particular tool, compliance test tool. So we have been asked for that. There was really a big need in the market. Everybody wanted to test the vehicles and nothing was available. So we decided to develop a compliance test tool. I must say, we have experience with compliance tests. We have already developed or partially developed a compliance test for J1979. We have developed a complete compliance test for worldwide harmonized OBD, just everything. And everybody who knows the SilverScan tool, we have adapted the official compliance test into our tool that can be used there. So we have quite a good experience with that. And so we decided to develop a separate product of array consulting. It is based on the idea of the J1979-3. It's still a command line application with a log file with raw data. We even decided to keep the numbering of the test cases so that everybody who is familiar with the J1699 will be familiar immediately with our compliance test. So we just stripped it down to ZEV-related test steps. We can still use pass-through interfaces, and it is capable to run both CAN and DoIP. And we use the same DoIP library for all our products. So it's for the compliance test, for Diagra S, for Diagra D, for SilverScan tool. So it's deeply tested. Further steps will be to integrate this tool or to make it available in the remote control window as well as the SAE tools, and creating an XML report. This is what we have planned. I just show how it looks like, a brief overview. We have this introduction part, with the selecting interface and protocol type, select the test type, the vehicle, with some vehicle information. And we still have these 5 main test cases. The numbering is the same from 5 to 9. It doesn't start with 1. And we have on the right side, you see the number of test steps, single test steps we have. So the first one is the one with no malfunctions, no DTC set. Next one is with pending code, the confirmed code. You see, we once more have the problem with the bouncing false, and what happens with fault repaired and with DTC is cleared. So let's look quickly in test 5 how it looks like. So we have once more the same numbers. You see we have some gaps here. It's jumping from 5.3 to 5.6 and so on. So we tried to keep really the number of the tests and just to do the corresponding part for ZEV. We renamed everything, so we have no engine, no ignition, no driving cycle. So in most cases we talk about PSA, so propulsion system active. This is how it looks like. So it's a command line window once more. So yeah, I think you're familiar with that, and we have the same type of log file, so that can be used. What is maybe one important thing for you if you are interested in that, in having this tool or using this tool? So everybody who has an active license of Diagra D and SilverScan tool can just contact us. We will unlock the license for this tool, so you can just use it, you can just download it. And we are really interested in feedback to that tool. If you have something that we should introduce further steps, just let us know. I think this is one of the differences to SAE, so we are more flexible. It's ready to use, so it's already available. And if you want to change or add some further tests, just let us know. So we have can rate quite good. So now time is going forward. We should hurry up. One quick view on our products. So you know, Diagra D, SilverScan tool, we talked about that, Diagra S. But beside that, we have our ODX tools, for example, the ODX viewer. We have the Diagra X. It's the measurement and calibration tool, and the viewer, Diagra X viewer, which is used to show MDF files. And we are working currently very hard on Diagra embedded version, embedded library for diagnostics. So I see we have 6 minutes left. Maybe you have some more time. So please, Alex.
Yeah.
So I hope that Malte has collected. You had some questions entered into the Q&A section. And Malte, do you have something burning question to us?
Thank you. Currently, we have only one question. It's a very specific question about DoIP.
Oh.
They ask, as per my last info, DoIP timings are not that relaxed. It depends upon the response length. In the worst case, minimum timeouts can be 100 milliseconds. Please correct me if I'm wrong here. Can you say something about this?
No, I think so. As far as I studied, or we studied the ZEVonUDS standard, there were no such strict requirements for that. So so 100 milliseconds. I understand. So for many use cases, it might be it might work like this, but for the whole response, I think it's too much, because some of the devices inside of a subnetwork might be CAN, so it might be forwarded to other parts of the vehicle, and then having the full response just after 100 milliseconds to build too less. So then the DoIP standard, even DoIP standard, defines it, with more is 2 seconds.
I rather think 100 milliseconds could rather be related to CAN. This is typical for example, for the first frame timeout. This is something that I could expect. If we have very long messages, it will take more time. So maybe we'll check that and answer your question afterwards once we have checked everything.
They added some additional information. It is in draft currently. Discussion already happened with German OEMs, just for your information.
Good, yeah. Okay, then if it's in draft, this is a bit different. So because we are referring to the one version which is published and which is referenced even from CARB regulations, and even from the draft from UNR 154. So the newer one is it's draft. I know there is a big working group doing good job on that, but so it's still not one available public for the whole public, for all of the people to implement it. So it's, for now we cannot rely on that, even if we know some part of the insights about that.
Mm-hmm.
Okay, thank you. We have 2 more questions. One short is about the J1979-3. Maybe you could clarify this. What is the benefit of using your version of J1699-3 via Silver Scan tool other than the official tool?
So we must be careful. You are talking, the attendee is talking about the J1699-3. So this is the compliance test tool for OBD Classic. So one thing, this is very important to know. There's only for heavy duty, light duty combustion engines, there's only one single tool that is allowed to use, and this is the one from SAE, the J1699-3. There's no other tool. And yes, you can use this in the Silver Scan tool and Diagra-D, but this is the original tool. We have not implemented an own one. We have only added a friendly user interface on that, the configuration user interface. But in the background, the original unmodified tool is running. Any other thing would not be allowed. So this is very important for you to know. If you use the J1699, the official J1699 together with Silver Scan tool, it's exactly the same. It's the difference is the friendly user interface. It saves you some time if you run a test multiple times, because all the information you have to enter at the beginning are in the user interface. One more question, Martin? Yeah.
Okay, thank you. One important question. Do we need to have Silver Scan tool license to be able to use your CT ZEV?
It's good if you have one, but it's also possible to get a license for the compliance test tool only. So you should contact our sales department for that. And but if you're already a Silver Scan tool or Diagra-D user, you can just use it. You can just get the license.
So with no additional cost.
Yeah, but it's really a standalone tool. It's not included in the code of Diagra-D. It's a separate tool. It's really the same or similar to the J1979. Still a separate tool. Okay.
Okay, thank
So
you.
that-
I'm afraid we don't have any time left for the last question.
Probably is it a complicated one?
It's about freeze frames.
Oh,
We can try. They ask, when we say we migrate to ZEVonUDS, it does not support freeze frame, means the ECUs implemented with this new protocol will not have the freeze frame data.
this is a question we could ask to the ECU suppliers. I think for repair, freeze frame is still used, but it's not required to show it via OBD protocol. So if you ask for a freeze frame in ZEVonUDS, maybe it's not shown. It's today in ZEVonUDS, it's hard to distinguish because it's nearly the same service. But I don't know how this is managed in the ECU. Finally, it's not required for ZEVonUDS. Okay, so we have 1 minute over time. Thank you for staying in the meeting. So we have a survey prepared for you in English and German. If you prepare German, you can use it, of course, but I expect, because this is the English edition of this webinar, just use the QR code on the right side if you want to use the survey. So it would be happy. Any feedback is appreciated. If you liked it, just let us know. Maybe we have another one of this webinar. So thank you for attending. Have a great day and see you.
Yeah, thank you. Bye-bye.